I had just put together a little talk of just how to get started trying to go into reverse engineering. I'm not going to go into like details of specifics, but just more of, I guess, kind of my thought process for how I reverse engineer things whenever I'm just curious about something that I want to reverse engineer. Um, so I guess first, what is reverse engineering? Well, the idea is mainly you're just trying to go backwards. You're trying to take a product or something that's been already created, whether that is software, hardware, or just anything, and try to figure out how it was created from its roots or how different parts of it work. Because staring at something like, say, one of these boards isn't exactly obvious of how some of this is supposed to operate. Like I can't look at a chip and be like, that's supposed to be a switch that determines if this light's on or off due to these conditions. I won't be able to figure that out. So I'll have to do some sort of reverse engineering. And the main idea is you want to go from, can I try to go from this finished product and then kind of pull it all apart to get to what the original creator's idea was initially. And that'll usually give you a good scope of what is going on. It's basically a backward puzzle. And what's really cool with this is with reverse engineering, it's kind of like taking apart someone's like a story, or it's like because everything that's created is always an art, in my opinion, and it's kind of cool to see, how what these people create. You get to learn the why and the how something was created, and sometimes you even get to learn the who. And especially when it comes to malware reverse engineering or trying to reverse engineer things that are created by nation states, you can even add some attribution potentially in there because there tends to be patterns and similarities because everyone has a style for how they create things. That makes it more interesting, in my opinion. So, what kinds of things can you reverse, at least, I guess, that are cybersecurity related? Well, there's software, firmware, and then there's hardware. There's also psychology. Now, that wasn't supposed to be a pun on reverse psychology, but the idea is kind of what I was saying before. This is something that someone has created. And sometimes it's kind of interesting to see how people think when they create something. And it kind of can lead to not just reverse engineering to figure out how something works, but potentially reverse engineering to figure out how you could take advantage or cause something to have an effect a different way that wasn't initially intended, which kind of leads into like hardware hacking or doing actual like software hacking and being able to exploit systems that maybe weren't initially at face value obvious that they could be exploited. So let's start reversing. So before we start actually diving in head first, let's try to make sure we kind of have our prerequisites. Can we understand the target? Do we have the prerequisite knowledge to be able to understand what we need to do or how we can understand the target? And that seems redundant, but it's more of like, do we like, so if it's like a software that's supposed to run on Linux, do we understand how Linux binaries work? Do we understand that we might need like a disassembler, and do we know how to read the disassembler? So while these things seem pretty trivial to maybe someone who's done this a lot before, it's a lot of times when you go into these new regimes of reversing that maybe you haven't touched before. So maybe you're really good at software but you've never touched hardware. You're not going to know the first thing that you're going to need to start necessarily reversing that product. And so you'll need to start trying to gather these techniques and understanding what tools you'll need that'll help get you to the end goal of at least trying to get a good picture of what's going on in the system. And then research similar activities. A lot of times, this isn't the first run at this type of technique that maybe you're doing. It's very evident in reversing that there is a large group of people that are doing reverse engineering on a broad scope of things. So if this is your first time going into maybe a Windows binary or a Mac binary and you're not sure how it works, well, go look up some papers, CTFs, look up research papers of people who have found O-days on different binaries that were coded to be for a Mac or for a Windows machine. And you end up learning these little techniques from them because a lot of times, especially for CTFs, they're trying to showcase something novel about that system. And so you end up picking up little tidbits along the way of not just understanding how they go about a certain method of reversing something, but also what are the little quirks kind of in between, because sometimes those are showcased. And so then you can, when you're doing your reversing, may not see it as often, but when you do, you know when to pick it out and you can pick up and be like, oh, well, this is because of XYZ reason. And then really just begin reversing. I mean, where do you dive in on that, which we'll go into in a second, but try to understand what the product is first. So if this is software, figure out how was it compiled? What was the purpose of the product? Like, why did they create it? And this comes into that kind of personal aspect. If I have a user database, the purpose for that being created was probably to maintain users and try to understand how, what users exist in the company. So, what kinds of things would go into that? Well, it would probably need to talk to a database. It would probably need to talk to, such and such, because if it needs to scale, it needs to be able to store those users somewhere. So then I'm going to start keeping that in mind and be like, okay, well, at somewhere along the way, I should expect to look for this. And so you start kind of trying to build out, like, if you were almost the developer of this program, how would you create it? And it kind of helps you guide along to figuring out, to making these little bits of assumptions, which talk about here in a second. You start making some assumptions to really figure out where do you actually would you expect to find certain functionality, and you start investigating that functionality. Play with the program, you start using it like a normal user, and then you investigate where those little tidbits are that you thought about before in kind of your pre-planning steps. And so it really helps to kind of put yourself in the idea of the developer to, I guess, get a better grasp on the bigger picture. Because sometimes, again, just looking at assembly, you're not going to understand what the program's doing immediately. Like, that's going to take a second. So you kind of have to walk through step by step, from the start of where the user starts interacting with it. What do my actions do, and how do those translate to the code? And then if something doesn't make sense, like, or maybe a function is not clear how it works, I can maybe treat it as a black box and be like, well, this is probably going to be something that's taking a user input and doing something with it and then storing it somewhere. And so that where that's going, well, we said it's probably a database, but I don't exactly know what they're doing in that function. So what common things would, as a developer, I probably try to do whenever I'm storing a user's credentials or something into a database? Well, maybe I might do like hashing. So maybe that giant complex block, instead of me just having to go through and figure out exactly bit by bit what it's doing, now I can be like, oh, that's probably a hashing algorithm. And so I'll just throw that away without even knowing that it was probably a hashing algorithm. And maybe we're wrong, but the part of the assumption is to come back and check it later. And this makes our analysis on anything a little easier. So I'm going to switch to an example program real quick that I made. I have a user management program, but I'm not going to use a database this time. But this is nice because this is a white box reversing. This is nothing that's compiled. I don't have anything too crazy going on with that. The user that created this, we don't know who they are, but just given the code that I've gotten, I see that it's Python 3. The code is there's I can reverse this, I can figure out what it does, but I don't really want to do that yet. I want to use the program. I want to figure out what it is. So they've given me this environment that looks like, just looking at the Python here. So I'll say Python version, and it looks like the version of Python that they're giving me is Python 2. So it's kind of interesting because this is also more of a ism in Python, but this is a little weird that they gave me a Python 2, but at the top of the script, it was defined Python 3. But that's fine. I'll go ahead and I'll use their script. I'll see what it does. So using it, we have a user management menu that we're given, and we can store an ID, delete an ID, print IDs. So I'm just gonna, store an ID. So I'll store 1237, and it added it. And I can print the IDs here, it seems. All right, that makes sense. I'm gonna add another ID. Cool. And if I print it there, and then I can also delete them. Let's get rid of 1237. Cool. So the functionality is like really, like, there's not a lot going on here, but now I kind of have an idea of what's going on. So what did we gather from that? Well, we've gathered that it takes an input at some point from the user for this like little menu interface. Then each time that I do a store ID or delete ID, it's going to take an additional input, and then it's going to usually try to expect probably an integer. So, maybe I might try to summarize, as a creator of this, I'd probably be trying to do some sort of conversion somewhere. I want to take this ID from the user, which probably will come in as a string, and then convert it to an integer. So I'll keep that in mind. And then, maybe if I put an S here, well, that was a little weird because, sometimes I might try to say, like, if I put a character and then people try to cast that to an integer, it should fail. It should just crash. But this wasn't just like a failure or a crash. It said the name S was not defined. So, which is a little strange. And this is where having a little bit of prerequisite knowledge of the language that you're trying to reverse helps a little bit. With Python, this usually happens when you don't define a variable. So what's super strange about that is I didn't think that this means I might have control of variables that are just named S, or maybe if I do, so that was in the IED store, so like something. Well, something is not defined. So yeah, it looks like I'm just like able to like just have random variables there, which is super strange. I'm defining variables somehow. So we dive into the code, and this is where we can kind of follow along with our interaction here. So we see that there's some functions defined, and then a while true that has a menu. And on the left-hand side here, we notice that there's a menu that has looks like what would be like a switch case, and it checks to see if our input's 1, 2, or 3. And it uses this input function, which is fine if we're doing like Python 3. What's kind of more really interesting about this is they didn't actually do any direct conversions to an integer. So normally when you take in input from a user, right, it becomes a string, and they never converted it. So kind of strange, but we're also given a Python 2 environment, which means that it's for input in Python 2, you're supposed to use raw input, and input in Python 2 actually evaluates your code. So this is the reason why actually that we're having errors with our, just if we put a string in there. So we see this usage is like actually all over the place, which is even stranger. And so with not much, I guess, understanding any of the other functions, we immediately can pick out any usage of this function anywhere in the program. It's probably going to serve as a vulnerability, because if you're not too familiar with evaluation sandbox escapes, you can trivially in Python be able to execute arbitrary code this way, even getting a shell by doing something like, so for this ID here, you could do like one in this code. So this is an ls, and there's an interact, or we can even just do a bash shell, and then boom, we got a bash shell. So we've broken out of that program. This is a really simple case, but we didn't really have to pay much attention to what they were doing in some of these functions because we weren't necessarily curious about that. The functions were named really well, and even if they're not, we can kind of get an idea based on what the user output is here of what the purpose of each of the functions were supposed to be. So if we were reversing, say, an IDA, and this was a binary that we've never touched before and it's been completely stripped, we can start renaming variables based on just the strings that are in the binary and what the users, or at least what the programmer has put in there as to be more of like an interaction with the user. Of course, it gets harder the less strings that are in a binary, because for firmware, for example, doesn't always have just raw strings always. Usually it's not expecting the user to be able to, or they're not expecting to print out something to the user basically. But yeah, I mean, so it's, yeah, let me get out of that demo and we'll go to this. So some places to start, I think it depends on what you want to do. These are some general places I would recommend, at least for just starting reverse engineering things. Of course, this is like not exhaustive in the slightest. There are so many reverse engineering YouTube channels, websites, and books, but these are the ones that I've used probably the most recently for just referencing or for just understanding some other concepts. If you need specific knowledge, usually there's a book for it. So if I need specific knowledge about the ELF and how binary exploitation for ELFs work, or reversing for that, there's a book for that. So I would highly recommend, at least if you're interested in doing hardware hacking, to start with the hardware hacking handbook. That's like the Bible basically when it comes to hardware hacking, and it's a really good start in my opinion. But that is it. That's all I got today for today.